Welcome students to the session of panoramic physics. Students, today our topic of discussion is magnetic elements of Earth. Magnetic elements of Earth at a place are the quantities which describes completely in magnitude and direction about the magnetic field at that place. जो completely determine करता है direction को, magnitude को of particular place, that is your magnetic elements. हमने पिछले वीडियो में देखा था about geographic meridian, magnetic meridian, अर्थ के magnetic field का क्या cause था, what are basic evidence in that and what are basic theories about that. Now today we'll see what are magnetic elements of earth. तो magnetic elements of earth at a place, magnetic elements of earth at a place describes are the quantities, basically are the quantities. एक तरह की quantities होती हैं. These are basically a type of quantities which express about the strength of magnetic field, about the strength को बताती है magnetic field की, and they tell about the angle of declination and all. We'll study it. So magnetic elements of earth at a place are the quantities which describes, जो पूरी तरह से हमें ज्ञान देती हैं, which describes completely, but how completely in magnitude and direction. किस चीज का magnitude and direction of magnetic field of earth at that place. तो बेसिकली हमें जानकारी देते हैं, डिस्क्राइब्स कंप्लीटली अबाउट मैग्नीट्यूड एंड डायरेक्शन. किसका? मैग्नेटिक फील्ड ऑफ अर्थ का. तो अगर आप एक शब्द में बोलना चाहे तो जो हमें मैग्नीट्यूड और डायरेक्शन के बारे में बताए, ठीक है, ऑफ मैग्नेटिक फील्ड, दैट इज योर मैग्नेटिक एलिमेंट्स. Likewise we study them. We write magnetic elements describes completely in magnitude and direction about the magnetic field of particular place of earth, and that is with the help of these two things, magnetic meridian and geographic meridian. The very first term which we encounter while studying this concept is magnetic declination. ये क्या चीज है स्टूडेंट्स? यू कैन सी दिस इज योर जियोग्राफिक मेरिडियन, दिस इज योर मैग्नेटिक मेरिडियन. इनके बीच में बनने वाले एंगल को हम बोलेंगे मैग्नेटिक डिक्लाइनेशन. और यू कैन सिंपली से एंगल बिटवीन थीटा से इसको रिप्रेजेंट करते हैं. दिस इज मैग्नेटिक डिक्लाइनेशन. एंगल बिटवीन मैग्नेटिक मेरिडियन and geographic meridian is known as magnetic declination. इसे हम कहेंगे magnetic declination, represented by theta. Now next is your angle of dip. You can see over here, this is your declination. Now we'll concern about angle of dip. What is basically this angle of dip and what it represents? Let's see now. ये angle of dip क्या represent करता है? Is the angle between the total strength of Earth's magnetic field. Total strength कितनी है Earth's magnetic field की, and the total strength of horizontal component and the horizontal line in magnetic meridian. Magnetic meridian में delta क्या है? It is that angle which defines total strength. जब हम angle of dip की बात करते हैं, then we talk about strength. तो angle of dip basically क्या define करता है? Angle of dip is defined as the angle between the total strength. किसकी strength? Of Earth's magnetic field. Total strength of Earth's magnetic field and the horizontal component एंड द हॉरिजॉन्टल लाइन इन मैग्नेटिक मेरिडियन। तो ये मैग्नेटिक मेरिडियन में जो हॉरिजॉन्टल लाइन है रिप्रेजेंटेड AL। तो दिस लाइन और इसके बीच का जो एंगल है टोटल स्ट्रेंथ का इज योर एंगल ऑफ डिप, दैट इज योर डेल्टा। इसे हम डेल्टा से रिप्रेजेंट करते हैं स्टूडेंट्स। बेसिकली वर्टिकल और हॉरिजॉन्टल के बीच में बन रहा है ये एंगल, तो दिस इज योर डेल्टा। नाउ थर्ड कंपोनेंट विच इज वेरी अच्छा, वन मोर इंपॉर्टेंट इंफॉर्मेशन, एंगल ऑफ डिप वेरीज अकॉर्डिंगली। द वैल्यू ऑफ डिप एट प्लेस इज, इसकी वैल्यू वेरी करती है 0 डिग्री टू 90 डिग्री। डेल्टा वेरीज 0 to 90. It varies from 0 degree to 90 degree. The value of dip is 90 degree at poles. Poles पे ये value है 90 degree. Poles 90 degree and at equator its value is 0 degree. It is the way it varies. Equator पे ये 0 degree है और poles पे this angle comes to be 90 degree. Now we will study next relation, that is relation between, let me rub this. So we have defined angle of dip, angle of this is what before going for relation between angle of dip and others, let me study one more thing, that is your horizontal component. What is horizontal component? Now horizontal component of strength of Earth's magnetic field, Earth's magnetic field in horizontal direction. In horizontal direction. This is the third component of magnetic elements. So theta, angle of declination is there, angle of dip is there, and H here, horizontal component of strength of Earth's magnetic field in horizontal direction. Now students, next we will go for the relation between horizontal and vertical component का आपस में क्या relation है? Relation between horizontal and vertical component. Let's do it. Relation between horizontal and vertical component. Very very important. Vertical component of Earth's magnetic field. Component and magnetic dip, इन सब का आपस में क्या रिलेशन है? एंड मैग्नेटिक डिप आल्सो इंक्लूड, एंड मैग्नेटिक डिप, इन सब का आपस में क्या रिलेशन है? लेट ABCD इज अ मैग्नेटिक मेरिडियन। आप देख सकते हैं यहाँ पे ABCD। लेट ABCD इज मैग्नेटिक मेरिडियन, एंड यू कैन से हियर AB'C''D. AB'C''D is the geographic meridian. तो दो तरह की मेरिडियंस क्लियर हैं. वन इज योर मैग्नेटिक मेरिडियन, अनदर इज योर जियोग्राफिक मेरिडियन. दिस वन इज योर मैग्नेटिक मेरिडियन. इसकी बात हम करें, दिस इज योर मैग्नेटिक मेरिडियन, दिस थिंग, एंड next one is your geographic meridian. Now let's see how to find this component. Let angle B'(AB) is theta. This is your B'(AB) is theta. Likewise we proceed. Let's do it in detail. So students, now angle BAB is theta, that is magnetic declination. B'(AB) is your theta. Angle BAK is your delta, that is magnetic dip at that place. AK is R, this thing R, that is the total strength of Earth's magnetic field. AL here is the horizontal component, and this AM is your vertical component. Let H is now horizontal component is given R cos delta, and R is rolled into two components. One is cos component, which is along the horizontal, and another is your R sin delta, which is your vertical component. So students, when we add and squaring them, what we'll get? We get the value of R, that is your under root h square plus v square. You want to know how it comes? It's very simple to get the answer. Let's see. Now see, squaring and adding, that it comes out to be h square plus v square equal to r square sine square delta plus cos square delta. That is your 1 implies r is equal to under root h square plus v square. Now on dividing second by first, on dividing second by first, what we will get, that is v vertical upon horizontal, r sin delta upon r cos delta. Here r get cancelled out, we get tangent delta, that is vertical upon horizontal component, which will be equal to your tangent delta. Students, there are various numericals based on this, and they are very simple and directly based on the application. इसकी application पे directly based होंगे वो numericals. Let's see how we'll go for them. Very simple numerical. Let's see. Very simple numerical. We do horizontal component of Earth's magnetic field at a place. Horizontal component of Earth's magnetic field at a place is under root 3 times the vertical component. Let vertical component be x and horizontal component is under root 3 times x. It is given. कि horizontal component under root 3 times है. Horizontal component is given है. Horizontal component is under root 3 times the vertical component. Vertical component का under root 3 times है. And it is asked what is the value of dip at that place. You know tangent delta is vertical upon horizontal component. So the vertical component is x under root 3 and this get cancelled 1 upon under root 3. So delta comes out to be here, that is your tangent की कौन सी value होगी 1 by root 3, that is 30 degrees. So this is your answer. So this is the way we could find the angle of dip, inclination, declination and all the aspects of magnetic elements. Students, revise it thoroughly.